Have you ever heard of tardigrades? I'm sure you have. They're the hardy little microorganism that's become the go-to topic for pop science periodicals, because they're just so darn neat. They have 6 legs and a beefy little puckered-looking proboscis for a mouth, and they can survive extreme conditions. They can survive long periods without food and water. They can endure extremely cold temperatures, and they can tolerate heavy doses of radiation. Keep in mind, however, that while they can survive these things, they don't thrive. In almost all circumstances where they're exposed to these extreme environmental variables, the tardigrades are only able to survive because they go into dormancy. They basically shut down. For example, in the case of enduring extremely cold temperatures, they have proteins in their body that will help the tissues freeze in a safe manner, and the tardigrade effectively takes on the consistency of glass. All of these traits, from cold tolerance to radiation tolerance, will come in handy for a particular population of tardigrades, who have crash-landed on the moon. Yes, that's right. The moon is now inhabited by terrestrial life forms, although, all things considered, they're probably dead. So here's what happened. A man named Nova Spivak is the founder of the Attribution Foundation, which is a non-profit organization whose goal is to create, quote, a backup of planet Earth, unquote. The organization intends to put all human knowledge into archives, or time capsules, that will then be stored around the solar system so that they can be preserved for millions, if not billions of years. These archives are about the size of a DVD player, and they store tens of millions of pages of information. The first archive that they launched is now in the glove compartment of Elon Musk's car, which is in an orbit around the sun. Mr. Spivak and the Attribution Foundation had created another archive with even more information, like languages, textbooks, classic novels, the English Wikipedia, and even genetic data, like samples of tissue from the human researchers, and samples from various plants and animals. One of the animal samples included thousands of dehydrated and thus dormant tardigrades. This particular archive was placed on board the first privately funded lunar mission, the Biologic lunar lander, operated by the Israel Aerospace Industries. The mission launched earlier this year, and on the night of April 11th, it was scheduled for a touchdown on the moon, somewhere in the Sea of Serenity. Except, right as the landing thrusters began to fire to slow its descent, right as the lander was about to land, the data feed was lost. The lander had crashed onto the surface of the moon, and along with it, the archive containing thousands of dehydrated tardigrades. However, Mr. Spivak thinks his archive was not destroyed, and he thinks the decision to include tardigrades and DNA may be responsible for it not being destroyed. This is because, during the manufacturing process, the biological samples, including the tardigrades, were all laid down in layers of resin. All these layers of resin inside the archive made it extremely sturdy. Mr. Spivak said, quote, "Ironically, our payload may be the only surviving thing from that mission," unquote. The tardigrade's fate is still unknown. The extent of the destruction is still unknown. If the archive wasn't destroyed, then the tardigrades are most likely alive and still in dormancy, secured inside their resin-reinforced matrix. But if the archive was partially or completely destroyed, then the tardigrades are almost certainly dead, their little bodies being torn apart by the micro-serrations on the lunar dust. These dust particles haven't been eroded by wind or water, so they're extremely sharp and gritty, and they would probably cut and tear apart the microscopic body of the tardigrade on contact. If this doesn't kill them, the combination of extreme low temperatures, extreme radiation, and the complete lack of water will kill them. At the very least, it will render them dormant indefinitely. the moon isn't going to get a watery atmosphere anytime soon. So all of these extreme variables will be acting on the tardigrades in perpetuity until they die. Or until future human explorers are able to find them, bring them back into an atmosphere, and rehydrate them. But if this rehydration and reactivation process happens 1,000 years in the future, or even 100 years, or hell, maybe even 50, or 30, or maybe even 20 years into the future, the tardigrades will probably be dead. In laboratory conditions, they've only been shown to be able to survive dormancy and to be able to come back out of dormancy after just a little over a decade. On the scale of technological development and space colonization, at the rate that we're currently doing that, we're probably not going to go up to the moon and collect these tardigrades and see what happened to them, at least not within 10 or 15 years. So in the end, we didn't necessarily seed the moon with life. It's not as if these tardigrades are all happily alive and active, and will go on to colonize the moon, and we'll see the emergence of a lunar-adapted strain of tardigrade. I mean, that would be super badass, but that's not what's happening. This was more of a mission failure leading to a big mess, which may or may not have splattered biomatter across some craters on the moon. This is a perfect example of how easy biological contamination can happen, and it carries implications for our exploration of the rest of the solar system. I mean, this accident was just on the moon, which we're fairly certain is a barren, lifeless wasteland that's completely inhospitable to any type of cell. But it's a completely different story when we look at other moons in the solar system. We'll have to be especially careful not to contaminate moons that might host native life, like Enceladus or Europa. I think that we really have to be careful out there, otherwise we might contaminate entire worlds and disrupt a chain of evolution that has developed undisturbed and uncontaminated for millions or billions of years. In terms of space exploration and the search for alien life, this would be the most bittersweet possibility. We learn that alien life exists, which is amazing and incredible and something that the human species has wondered about for eons, for all of its existence. But in the very act of discovery, we disrupt it, we foul it up, and maybe even destroy it. In this sense, we would deny ourselves the chance to learn about a pure, unaltered petri dish full of alien life. And that would be a tragedy of indescribable proportions.